Okay, lesson number 7, combining transformations, part 1. We've looked at 3 types of transformations. Translations, our slides, our reflections, and then our stretches. So a brief review. If I replace x with an x minus h or y with a y minus k, we get a horizontal or vertical translation. If I replace x with a negative x, we have a reflection in the y-axis. If I replace y with a negative y, we have a reflection in the x-axis. If I replace x with a b times x, or a with an a times, or y with an a times y, we end up with vertical and horizontal stretches. So what we're going to look at is we're going to combine different types of stretches and see what happens. So what I'm going to do is I'm going to walk you through investigation number 1, and then I want you to pause the video and try to do investigation number 2 on your own, and then I'll go through investigation number 2. So in investigation number 1, we have the graph of y equals f of x. You're not told what the equation is, you just have to work with that equation. Sketch the image of the function after a horizontal stretch by a factor of 3 about the y-axis, followed by a vertical stretch by a factor of 2 about the x-axis. So if I do this, do each step one at a time. So if I look at the first one, a horizontal stretch by a factor of 3. Horizontal means that we are impacting the x-coordinates. So if I'm stretching this by a factor of 3, I'm going to multiply my x-coordinates by a factor of 3. So 2 becomes 6. Negative 2 becomes negative 6. My y, our x value right here is 0, so it will stay at 0. So after my horizontal stretch by a factor of 3, I have this image. The next step would be to do a vertical stretch by a factor of 2. Vertical implies that I am stretching the y-coordinates. So these two y-coordinates would stay exactly where they were because the y-coordinates on both of those points is equal to 0. The y-coordinate here, which is at 2, if I stretch it by a factor of 2, is going to go up to 4. So this becomes my final image. So now what we're going to do down here is we're going to reverse the order and see what happens. So if instead of starting with a horizontal stretch, if I started with the vertical stretch by a factor of 2, these points will stay exactly where they were, simply because the y-coordinate's equal to 0 when I multiply it by the stretch factor stays at 0. This point at 2 is going to become 4 because of that stretch factor of 2. And that is my image after the vertical stretch by a factor of 2. If I now take this blue image and I stretch it by a factor of 3 horizontally, I'm impacting my x-coordinates. So the x's here, which are at positive 2 and negative 2, if I stretch it by a factor of 3, become positive 6 and negative 6. My y value, which is at, or my x value here, sorry, which is at 0, will stay at 0. So my new image will look like that. So this is my final image in green again. If I compare the two images, except for the fact that I'm not drawing very accurately, my points, my anchor points are the same in all 3. We can say that the two images are identical. So does the order matter in the way that the two stretches were performed? No. Order is not important. Okay. Now what I want you to do is I want you to pause the video and I want you to try to go through investigation number 2 with your group or on your own. Wait about 3 minutes and then press play and go into the next part. Okay, so now that you've gone through this next part, let's go through this a little bit faster. What we are going to do is we are going to sketch the image of the function after a vertical translation of 3 units up. So if I take this picture and I take all of my y-coordinates and I move them 3 units up, this is the picture I get. So I've taken that entire image and I've slid it 3 units up. Then I am going to do a horizontal stretch by a factor of 2 about the y-axis. So horizontal is my x-coordinates. So I'm going to stretch my x's. -2 to -4, +2 to +4, 0 stays at 0, and there's the final image. With the graph below, we're going to reverse this. So we're going to start off with a horizontal stretch by a factor of 2. -2 becomes -4, +2 to +4, 0 stays as 0. So there's step 1. Step 2, move this entire image up 3 units. If we've done this correctly, what do we notice about the 2 images? They are identical. So in this case here, does the order in which a vertical translation and a horizontal stretch performed make a difference to the final graph? No, it does not. So again, to repeat the process, what I want you to do is pause the video now, work through investigation number 3, and then I will come back, or when you press play, I will continue doing investigation number 3. So if we look at investigation number 3, we're going to combine a vertical translation and a vertical stretch. So we are going to sketch the image of the function after a vertical translation of 2 units down and a stretch by a factor of 3. So vertical translation of 2 units down brings everything down 2 units, and here is my sketch. I am then going to vertically stretch this by a factor of 3. So all of my y coordinates will be multiplied by 3. So -2 would become -6. This is -2, it will become -6. This is 0, so it will stay at 0. This becomes my new image. That becomes my new sketch. In the next picture, what we're going to do is we're going to stretch by a factor of 3, and then we're going to translate 2 units down. So if I stretch this by a factor of 3, my y coordinates here that are at 0 will stay at 0. My y coordinate that is at 2 is going to move to 6. So this becomes my vertical stretched image by a factor of 3. I'm now going to take that image and I'm going to translate it 2 units down. Once I've taken that image and translated it 2 units down, if I compare the 2 diagrams, I notice that they're not the same picture. So does the order make a difference? Yes, it does. So if I combine a vertical stretch with a vertical translation, the order in which I do the transformation matters. Okay? Now we're going to look at pausing. So you're going to pause for 3 minutes, look at investigation number 4, press play, and then I'll do investigation number 4 with you. Okay, investigation number 4. Horizontal translation of 1 unit to the right. So if I move everything 1 unit to the right, this becomes my image. I then take that and horizontally stretch it by a factor of 2. So if I stretch this by a factor of 2, -1 becomes -2. +3 becomes +6. +1 becomes +2. So there is my transformed image. If I reverse the order and I stretch by a factor of 2 to begin with, so if I stretch this by a factor of 2, -2 goes to -4, +2 goes to +4, 0 stays where it's at, and there's my stretched image. If I then translate that image 1 unit to the right, there's my new picture. Are the pictures the same? No. So does the order matter? Yes. So again, order is important. So the question that comes up when does order matter? Well, we know that order does not matter when I combine two translations. If I go left or right and then up and down, it doesn't matter if I went up and then left or left and then up. If I combine two stretches, a horizontal and a vertical stretch, if I do horizontal and then vertical or vertical then horizontal, doesn't matter which way. If I do a translation and a stretch at right angles to one another, what that means is if I did a horizontal translation and a vertical stretch, or if I did a vertical translation and a horizontal stretch, the order does not matter because this impacts the y's, this impacts the x's. This is the x's and this is the y's. So even though I'm adding, this is being multiplied, it doesn't impact each other. Reflections and stretches, we looked at that yesterday when we were looking at our stretch values of a value less than 0. So again, the order doesn't matter. I could reflect then stretch or stretch then reflect. The order does matter when I'm dealing, first of all, with a translation and a stretch, or a translation and a reflection. If the translation and the stretch are in the same direction, a horizontal stretch and a horizontal translation, vertical stretch, vertical translation, the order is important because I'll end up with two different graphs if I don't use the consistent order. And the same thing with reflections and translations. So just like in math operations where we have BEDMAS, order of operations, we have an order for transformations. That order, unless otherwise indicated, is to stretch, reflect, and translate. Or sort it out. You can stretch or reflect or stretch, it's not going to matter which one, and then translate. So the analogy that I use is I always use a sports analogy. In sports, you start off by stretching. That's how you get ready for your game. You stretch, you warm up. Then you reflect. You think about the game, you get yourself into a mindset. Then you move into position for the game. So you start off by stretching, then you reflect, and then you translate. So the last thing that you're going to do is move left or right or up and down. So now we're going to look at the following examples. So class example number 1 is to describe a series of transformations required to transform graph A into graph B. So if I look at graph A to graph B, it definitely looks like there was a flip of some sort. If I take this graph and I flip it around, I get that picture, which now starts to align with that picture of B. So what did I do? I did a reflection in the y-axis. That was my first step. From that step, I moved the graph. This was my vertex point, and I moved it this way and then that way to that point. So how do I describe that movement? I went 2 units to the left and 3 units up. So translation, 2 left and 3 up. So if I apply those transformations in that order, I will end up from graph A to graph B. And then class example number 2. Describe a series of transformations required to transform graph A to graph B. So if I look at graph A to graph B, I went from a square to a rectangle. How did I do that? Well, I pulled the rectangle out horizontally. I stretched it. What did I stretch it by? Well, it went from a length of 4 to a length of 8. So that's going to be a horizontal stretch by a factor of 4 times 2 gives me my 8. So I have a horizontal stretch about the y-axis by a factor of 2. I do that factor of 2, this becomes my new shape. That's my new shape. I then have to take this shape and move it to this point here. So pick a vertice. I want to move this vertice to this vertice. How do I do that? I went 4 units to the left and 7 units down. So then I have a translation, 4 left and 7 down. And that'll bring me from picture A to picture B. So now if I want to go from graph A to graph C. So if you need to pause for a moment, I'm going to erase that image. So if you want to pause it till you have it written down, and then press play again. So part B, I'm going from image A to image C. So what happened? I pulled it up. I did a vertical stretch. I have a length of 4 to a length of 8. So now I have a vertical stretch about the x-axis by a factor of 2. So if I do that transformation, this is -2, it's going to move to -4. This is +2, it's going to move to +4. This becomes my new picture. I then have to move this picture to this position. So again, pick a point on the graph that you can move, one of the corners. How did I make that movement? I went 1, 2, 3, 4, 5, 6 to the left, and then I went 4 up. So now I have a translation of 4 left, or sorry, not 4 left, 3, 6 left, and 4 up. So a vertical stretch by a factor of 2, and then a translation, 6 left and 4 up, will bring me from image A to image C. Again, press pause if you need a couple of moments to write this down. I'll erase the graph, and then we'll do the last image from B to C. So B to C, there's a couple of things going on. So I can look at this a couple of different ways. If I wanted to, I could look at this as being, I took this graph and I shrunk it. So I did a horizontal stretch by factor this time of 1/2, from 8 to 4. So horizontal stretch by factor of 1/2. So if I do that, it's my x coordinates that are becoming 1/2. So this 8 becomes 4, or -4. These are on 0, so they're going to stay at 0. There's my first picture. Then I can do a vertical stretch by a factor of 2. So if I do a vertical stretch by a factor of 2, 5 will become 10. So it's going to go down here, or -10. And this dot right here, which is at 9, is going to become -18. And it's important that we know what those will become, because when I go to now translate this to this point, I need to make sure my translation's done correctly. So now that I've done that, if I go to translate, let's say if I bring this point to that point, I have to go 4 units to the left. So now I translate 4 left, and then I'm going to go, so I'm at -10, and I have to go up to +8. So 10 units and another 8. I'm then going to go 18 up. Okay? There's another possible answer. So again, if you want to press pause, I'll erase this and I'll do the other answer for this question. So the other way that I could look at this question is I could look at a reflection in that line of y equals x. So if I did a reflection in the line y equals x, it's inversing all of my coordinates. So this coordinate right here is at 0 and -5 becomes -5 and 0. This coordinate here, which is at 0 and -9, becomes -9 and 0. This coordinate here, which is at -8 and -5, becomes -5 and -8. And this coordinate right here, which is at -8 and -9, becomes -9 and -8. So here is my image after that reflection. So we have a reflection in the line y equals x. And then from here, I'm going to shift this entire graph up. So again, I can look at these 2 points. To go from this point to this point, I go 1 unit to the right. And then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 units up. Okay. So now I'm going to go through and I'm going to finish the last part of the examples, and then you'll have the remaining part of class to work on all the questions. So class example number 3. Describe which transformations are applied to a graph of a function when the following changes are made to its equation. Does the order in which the transformations are performed affect the final graph? So if I replace x with a 3x, what do I have? I will have a horizontal stretch by a factor of 1/3, because it's going to be the reciprocal. And then when I replace y with a y plus 4, I will have a translation of 4 units down, because this was actually a y minus -4. So that's what prompts it to move down. Does the order in which the transformations are performed affect the final graph? Well, let's check. If this was y equals f of x, if I replace x with a 3x, I get y equals f of 3x. If I replace y with a y plus 4, this is the graph I get. If I reverse it, if I replace y with a y plus 4, I get this. Replace x with a 3x. What can you tell me about the 2 equations? They're the same. So did the order affect the final graph? No. Order does not matter. And again, it's because this was horizontal and this was vertical. They were at right angles to each other. Okay, let's look at the next one. If I replace x with a 2/3 x, that is going to be a horizontal stretch by a factor of the reciprocal, which would be 3/2. If I replace y with a -3y, I have a vertical stretch by a factor of 1/3 and a reflection in the x-axis. And then finally, if I replace x with an x plus 2, I have a translation 2 units left. Okay, together, replacing in my y equals f of x, I would get y equals f of 2/3 x. That's this replacement. Vertical stretch of a 1/3. I now get 1/3 y equals f of 2/3 x. Reflection in the x-axis. Oh, sorry, there should be a 3y. There we go. Reflection in the x-axis brings this to be a -3. And then translation of 2 units to the left means I would have 2/3 of x plus 2 in brackets, because it's the x that gets replaced with an x plus 2. If I start from the bottom and go up, I will have y equals f of x plus 2. Then I have the reflection in the y-axis and a vertical stretch by a factor of 1/3, or the replacement with a -3y. So I get -3y equals f of x plus 2. And my final step is to replace x with a 2/3 x. Are these two equations the same? No. In this equation, the x plus 2 is in its own set of brackets, and in this equation, it's not. So the order matters. Okay, final question. The graph of a parabola y equals x squared plus 1 is shown. The following transformations are applied to the graph in the order shown. So the first step is to do a horizontal translation of 2 units to the left. What we are supposed to do is graph the image on the grid, write the replacement for x or y, and the current equation in the table. So if I do a horizontal translation of 2 units to the left, I would replace x with an x plus 2. On my equation, what that does is y equals x plus 2 squared plus 1. That becomes my equation. I'm not going to worry about expanding this out. I'm just going to leave it as it is for now. So if I move this entire graph 2 units to the left, pick points that are on the graph that you can see. So 2 units to the left. 1. So there's 2, 2. This becomes 2. There's 2 to the left, and there's 2 to the left. So I've taken these anchor points here and here on the graph, and I've all moved them over 2 units to the left. And there's my new parabola after the first transformation. Next, we do a reflection in the x-axis. If I do a reflection in the x-axis, that's replacing y with a -y. So my current equation would now be -y equals x plus 2 squared plus 1. If I bring the negative over to the other side, so that's multiplying everything by -1, the y becomes positive. The first term becomes negative, because it's multiplying this whole thing by a negative. So if I think of the distributive property, negative goes to this term, and negative goes to the positive 1. So it becomes -1. So reflection in the x-axis means I reflect it over this way. So these points have to be equal distance away from the x-axis. And then this one is 3, 6. This point here is wrong. There we go. I think I have this top picture. Let me fix that. This had to move 2 units to the left. There we go, that's better. dots. 2 to the left, 2 to the left, 2 to the left, 2 to the left, 2 to the left. So then this point translates down to here. This point translates to here. Left, 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 left. Down. This is at 0 and 5, so now 0 and negative 5. 1 and 10 becomes 1 and negative 10. And this one is at there we go. That's a better picture. Vertical stretch about the x-axis by a factor of 0.5. Vertical stretch means I'm replacing my y's. Factor of 0.5 is a factor of, a factor of 0.5 becomes a replacement of 2. Because replacement is the reciprocal of the factor. So now I have 2y equals negative x plus 2 squared minus 1/2. And then if I divide everything by 2 or multiply by 1/2, I will get 1/2 negative 1/2 x plus 2 squared minus 1/2. So that's taking all of my y coordinates and multiplying it by a factor of 0.5. So this is at negative 10. It is now going to move to negative 5. This one that was at negative 5 moves to 2.5. 1 moves to 0.5. 5 moves to 2.5. And 10 moves to 5. So this becomes my vertical stretch by a factor of 0.5. And then my last transformation is a vertical translation of 3 units down. So vertical translation of 3 units down means I replace y with a y plus 3. So if I replace y with a y plus 3, I have y plus 3 equals negative 1/2 x plus 2 squared minus 1/2. Bring the 3 to the other side, so now I'm going to subtract 3 on each side. And I get negative 1/2 x plus 2 squared. And negative 1 minus 3 is negative 3.5 or negative 7/2. Don't use mixed numbers, change it to an improper fraction. So now I'm going to move these points here 3 units down. So this point goes 3 units down, 3 units down, 1, 2, 3 units down, 1, 2, 3 units down, 1, 2, 3 units down, and 1, 2, 3 units down. So these 2 points here are actually sitting at negative 5.5 on the vertical axis, and this point here is sitting at negative 3.5. And there's my final image. Write the equation which represents the final position of the graph. And then I can verify it by putting it into the graphing calculator. Okay. Mr. Grant has a copy of the solutions or this lesson for you guys to look at for reference, and also for you guys to be able to help figure out where the points are on this graph, because I know it's a little bit harder to see with the whiteboard. So the questions that I want you guys to work on are questions 3, 5, 7, 8, and 9. These will be done for Friday. Tomorrow you have the ELA event and working on a review assignment, which I will have ready for you tomorrow morning, or Wednesday morning, I guess. And then Thursday you will have your quiz. Your quiz will be on lessons 1 through 5. 1 through 5 on the transformations. So that's translations, reflections, and the beginning part of the stretches is what your quiz will be on. That's it. So now you have the remainder of class to work on these questions. See you guys later.